last class, yesterday I explained that reduced the polynomial as linear, right?
Yes.
Okay. How many questions over? 2. In the textbook also 2 questions are there. And one more ma, I explained the theorem statements. నేను ఇచ్చాను మీకు థీరమ్ స్టేట్మెంట్స్ ఏమైనా థీరమ్ స్టేట్మెంట్స్ ఆల్ ఆర్ దేర్
Yes, ma'am.
స్టేట్మెంట్స్
Yes,
ఏమైనా ఇచ్చానా
No, ma'am.
నో ఓకే అండ్ Cayley Hamilton లో ఓన్లీ వన్ క్వశ్చన్ ఈజ్ ఓవర్ ఫర్ ఫైండింగ్ A inverse A power 4 and verification. But tell me anyone, regular students.
అంటే మ్యామ్ సెకండ్ క్వశ్చన్ కూడా ఇచ్చారు మ్యామ్ మీరు నేను
క్లాస్ లో ఒకటి చెప్పాను, ఒకటి హోంవర్క్ ఇచ్చాను. ఒకటి క్లాస్ వర్కే ఇచ్చా కానీ మీరు చేయలేదు అది అంతే కదా. Why? Because again I'll explain that one or else I'll start the theorem statements. That's why I'm asking. మీరు ఏదో ఒకటి క్లియర్ గా చెప్పండి. Why? Because in all sections second unit over మా మీ సెక్షన్స్ కి క్లాసెస్ నాకు మిస్ అయినాయి, దానివల్ల మీది లేట్ ఉంది సిలబస్. మీరు క్లియర్ గా ఇస్తే నేను ఐ విల్ కంటిన్యూ దట్ Cayley Hamilton ఫర్ ఫైండింగ్ వెరిఫికేషన్ అండ్ A inverse అండ్ A power 4 ఇంకొక క్వశ్చన్ చెప్దాం. లేదంటే ఐ విల్ స్టార్ట్ ద థీరమ్ స్టేట్మెంట్స్. ఒక 12-13 థీరమ్ స్టేట్మెంట్స్ ఉన్నాయి, అవి ఇచ్చేస్తా. ఏం చేస్తాం, ఎన్ని క్వశ్చన్స్ అయినా మీరు ఎగ్జాక్ట్ గా చెప్పండి. ఎనీవే ఎనీ డౌట్స్ ఇన్ Cayley Hamilton, it is simple method only procedure. That's why I'm explaining in the classroom, right? Okay, I'll give few more questions for the practice. After that I'll start theorem statements. Okay na? Okay ma.
Okay,
I'll
ma'am.
ask the answers for that questions. Madam కనబడట్లేదు మ్యామ్, ఏమి హోంవర్క్ ఇచ్చినా మేము చెయ్యము అంటే రేపు వీడియో ఆన్ చేయాలి, నేను ర్యాండమ్ గా పిక్ చేసుకొని వాళ్ళ ఆన్సర్స్ అడుగుతా. ఓకే
ఓకే మ్యామ్.
చేసుకోండి రా. I'll check each and every one. Write down one question for the practice. Not now. If verify Cayley Hamilton theorem. Verify Cayley Hamilton theorem. For A is equal to 1 2 minus 1. Is it over? Once you check it in the notebook. 2 minus 2 1 and find A inverse and A power 5. How many are completed question bank questions in holidays? ఇప్పుడు కూడా హాలిడేస్. ఓకే అమ్మా, is it repeated question or not? ఇది ఉందా నోట్బుక్ లో? ఈ క్వశ్చన్ ఫస్ట్ క్వశ్చన్ ఏం చెప్పలేదు కదా.
నో మ్యామ్.
Okay, note down that and I'll give one more question. For the same method, 8 minus 8, 2, 4 minus 3 minus 2, 3 minus 4, 1. Note down these two questions fastly. I'll explain the theorem statements after this. Fast copy చేసుకోండి. ఏమో
మ్యామ్ నిన్న చెప్పిన క్వశ్చన్ కి ఏ ఇన్వర్స్ ఇంకా ఏ పవర్ 5 చెప్తా అన్నారు మ్యామ్.
నిన్న ఏ క్వశ్చన్ చెప్పాను? అదే మరి నేను ఫస్ట్ నుంచి అడిగేది ఏంటి మీకు? కెలీ హామిల్టన్ థీరమే చెప్పానా?
ఎస్ మ్యామ్.
ఏ ఇన్వర్స్ ఏ పవర్ 4 నేను ఎక్స్ప్లెయిన్ చేస్తానన్నానా?
ఏ పవర్ 5 మ్యామ్.
అదే ఏ పవర్ 5 వాట్ ఎవర్ ఇట్ ఈస్. ఓకే, పవర్స్ ఆఫ్ ఏ. ఓకే, మన ముందు స్టార్ట్ చేయకముందు చెప్పాలి కదమ్మా. ఎనీవే వినోదా, ప్రొసీజర్ తెలుసు కదా, మీరు చెయ్యండి. ఏ ఇన్వర్స్ అండ్ ఏ పవర్ 5 ఇప్పుడు చేయండి, ట్రై చేయండి. ఇప్పుడు ఒక 2 minutes లో ఫాస్ట్ గా చేస్తారా లేదా? మీరు అది చేస్తూ ఉండండి. నేను ఐ రైట్ ఇట్ ఆన్ ద బోర్డ్ ద థీరమ్ స్టేట్మెంట్స్. ఫాస్ట్ గా కంప్లీట్ చేయాలి. డోంట్ రైట్ ది స్టేట్మెంట్స్. Now I'll ask the answer for the previous question, A inverse and A power 5. I have 3 sections నానా. మీకు ఏ టాపిక్ చెప్తున్నా అన్నది మీరు ఒక్కసారి నాకు స్టార్టింగ్ చెప్తే నేను దాన్ని బట్టి ఫాలో అవుతా. ఓకేనా? ఎందుకంటే వేరే సెక్షన్స్ కి నేను వేరే క్లాస్ తీసుకుంటున్నా. ఐ మీన్ 3rd యూనిట్ స్టార్ట్ అయిపోయింది మీకే, ఇంకా ఇక్కడే ఉన్నా. సో నేను కొంచెం గుర్తులేదు నాకు ప్రీవియస్ ఆ ప్రాబ్లం చెప్పి కంటిన్యూషన్ అవ్వలేదని గుర్తులేదు నాకు. Copied ma these 2 questions? Okay, last question continuation చేస్తూ ఉండండి. Now I'll write it on the board. The theorem statements. The theorem statements also important here. Okay, first one, the eigenvalues of A. The eigenvalues of A diagonal matrix. Diagonal matrix are just the diagonal elements. Are just the diagonal elements of a matrix. Elements of a matrix. Okay, this is the first statement. Next, if lambda is an eigenvalue, lambda is an eigenvalue of a matrix A, then k lambda is an eigenvalue of k. Next, third one, if lambda is an eigenvalue of the matrix, my only theorem statements here, no proofs in your syllabus, only write down the theorem statements and that related examples. Okay na? If lambda is an eigenvalue of a matrix A, k is non-zero scalar, then lambda minus k is the eigenvalue of A minus ki. This is the third one. Next, if lambda 1, lambda 2 and so on up to lambda n are the eigenvalues of A, then lambda 1 minus k, lambda 2 minus k, and then so on up to lambda n minus k are the eigenvalues of the matrix A minus Ki. Next, fifth one. If lambda 1, lambda 2, and so on, lambda n are the eigenvalues of A, then the eigenvalues of B is equal to A naught A square plus A1A plus A2I is A naught lambda square plus A1 lambda plus A2. Anyone finished the previous question? Anyone got the answer for the A inverse? Or simply all are writing these statements? Huh?
Yes, ma'am.
Your voice is not clear. Finished? Anyone got the answer for the A inverse? Tell me. Tell me the
1 by
answer.
3, 1 by 3, 0, 1 by 3, 2 by 3, minus 1 by 3, 0.
Okay.
2 by 3, minus 2 by 3, 1 by 3, ma'am.
2 by 3 minus 2 by 3, 1 by 3.
Yes, ma'am.
Okay. All got that answer. Maybe once we check the last row, 2 by 3 maybe minus 1 by 4 minus 1 by 4 anukunta answer. On singular matrix A, then det A by lambda is an eigenvalue of the. Okay, just leave for that question mark for half page. After that, continue the statements. Write down heading is statements, important statements all. Is an eigenvalue of the matrix adjoint A. This is very, very important. Last sixth one. Sixth one is very important. If lambda is an eigenvalue of a non-singular matrix A, then det A by lambda is an eigenvalue of the matrix adjoint A. If any bits-wise, if they are asking what are the eigenvalues of adjoint A means, what is the formula here? Det A by lambda. How you got det A here? Det A ఎట్లా వస్తుంది మరి మనకు మ్యాట్రిక్స్ లేకుండా ఓన్లీ దే ఆర్ గివెన్ ఐగన్ వాల్యూస్. Okay, from that we have to find out adjoint A eigenvalues. From one of the property, product of the eigenvalues is equal to what? Determinant of A. From that property we got det A, and after that substitute det A by given eigenvalues. Det A by first eigenvalue, comma det A by second eigenvalue, comma det A by third eigenvalue. For that we got directly adjoint of A eigenvalues. Is it clear all of you? For the sixth statement. Is it clear? Girl side and boy side. Ma, please, all of you on your videos, ma. Videos on hand. Or else today I'll cut the attendance for all the section students. Please on your videos. No one is giving response, huh?
మ్యామ్
Tell me.
సెకండ్ పాయింట్ లాస్ట్ లో ఏంది మ్యామ్ ఇది?
Second
పాయింట్ లాస్ట్
if lambda is an eigenvalue of a matrix A, then k lambda is an eigenvalue of Ka.
KA.
Okay. A.
మ్యామ్ ఫిఫ్త్ స్టేట్మెంట్ లో సెకండ్ లైన్.
Fifth statement లో second line, then the eigenvalues of B is equal to A0 A square plus A1 A plus A2 I. A1, that is A1. You finished? 6. Okay, finished one. 6 properties, I mean 6 statements. Huh?
Ma'am,
Oh, tell me.
can you explain sixth point once again, ma'am?
Okay, if lambda is an eigenvalue of non-singular matrix A, then det A by lambda is an eigenvalue of the matrix adjoint A. I'll give one example, ma. After that, it is very clear. Okay, shall I rub the first all statements?
ఎస్ మ్యామ్.
Okay,
Yes, ma'am.
now I'll give an example for the 6th one. It is important for bits wise. Now, first of all, note down all the statements. After that, I'll explain the each and every statement examples wise. Okay, na? 6th one over. Now, write down the 7th one. 7th one, write down if the eigenvalues of a real symmetric matrix are always real. Are always real. And the next property, the eigenvalues of A. But tell me the skew symmetric matrix eigenvalues. Similarly, tell me anyone. The eigenvalues of A. Tell me anyone. Skew symmetric matrix are always. Ma, what are the diagonal elements in symmetric matrix and skew symmetric matrix? Tell me. Skew symmetrics lo emuntayi?
ఇమాజినరీ
ఇమాజినరీ ఇమాజినరీ
Hermitian కాదు ఇది సిమెట్రిక్. నెక్స్ట్ రైట్ డౌన్ జీరోస్ ఉంటాయి. నెక్స్ట్ ద ఐగన్ వాల్యూస్ ఆఫ్ ఏ హెర్మిషియన్ మ్యాట్రిక్స్ ఆర్ రియల్. Next, 8th one, the eigenvalues of a skew Hermitian matrix are, tell me. For this, tell me, ma, what about the property of skew Hermitian matrix diagonal elements? Imaginary or zero, right? Imaginary or either imaginary or zero. Here write down either imaginary or zero. Next, ninth one. The eigenvalues of a unitary matrix. Unitary matrix have absolute value 1. And the 10th one, the eigenvalue of an orthogonal matrix. Orthogonal matrix can be plus or minus 1. Okay, note down this. After that, I'll give the example for the 6th one. Okay, the eigenvalues of an orthogonal matrix can be plus or minus 1. Okay, finished? Finished, ma? Huh?
Yes, ma'am.
Already I discussed in the previous class the diagonal elements. Diagonal matrix ki what are the eigenvalues? That diagonal elements only the diagonal value eigenvalues for the diagonal matrix, right? That is also one property. And here next property and second one Japani, if lambda is an eigenvalue, then k into lambda is an eigenvalue of k lambda. Okay, okay na? K means one constant ante. K annadi oka constant. If lambda is an eigenvalue aite, then ka matrix eigenvalue emoutundi k into lambda. And one more property, important one, if lambda is an eigenvalue of the matrix A, then polynomial form. Once you see ma fifth one or fourth one, B is equal to A naught A square plus A1A plus A2. For that, what is the eigenvalue? A naught lambda square plus A1 lambda plus A2. For example, make oka 3 eigenvalues ichi polynomial eigenvalues find out cheyamante. For example, if lambda is equal to 1, 2, 3. For that, find B polynomial eigenvalues. That means A naught lambda square, A1 A square, A1A plus A2. For that, find eigenvalues means how you find? Okay, find eigenvalues means eigenvalues. That means what's the concept of that? B polynomial ki how we are finding the eigenvalues? That is B is equal to A naught lambda square plus A1 lambda plus A2. Here what is lambda? Ma first value 1. Then substitute here. That is 1 plus a11 plus a2. Okay. That is first eigenvalue for the polynomial. And similarly substitute 2 and substitute 3. Okay. a0, a1, a2 unknown values. If the question, if it is in the question, if they are given a0, a1, a2 and lambda values, means directly we got b value is one numerical value, right? Or else we got the answer in the polynomial form. Okay, that is one statement. And one more important statement, if eigenvalues lambda are the eigenvalues, then adjoint A eigenvalues are what? Adjoint A eigenvalues are det A by lambda. Okay, if lambda is equal to 1, 2, 3, then find adjoint A eigenvalues. Then find adjoint A eigenvalues. For that case, formula adjoint A eigenvalue formula enti? Eigenvalues formula det A by lambda. Det A by lambda. Here what is det A? From the theorem statement, product of the eigenvalues is equal to what? This is also important bit. I gave the questions on this one also. Product of the eigenvalues is equal to what? Product of the eigenvalues is equal to det A. Here what are the eigenvalues? 1, 2, 3. Just multiply 1, 2, 3 is equal to det A. From that we got det A is equal to how much? 6. Okay, therefore adjoint A eigenvalues, okay, that is det A by. Here how many eigenvalues are there? 3. Let us take first one as lambda 1, comma, det A by lambda 2, comma, det A by lambda 3. For that, what is det A? 6. For the first eigenvalue here, 1. And the next 6 by lambda 2 as 2. And the det A by lambda 3 means 3. For that, 6 by 1 means how much? 6. 2 3s, that is 3. And 3 2s, that is 2. Therefore, adjoint A eigenvalues are what? 6, 3, 2. Okay, na? This is the procedure for finding adjoint A eigenvalues from the given theorem statement. Is it clear, all of you? Any doubts? Note down, ma. Note down this example. Finished?
Yes, ma'am.
Okay. These are the statements, ma. Just by heart it. Okay. And for this type of questions are important for the bits wise, not for the long answer questions and all. In your syllabus only statements in previous years. Okay, theorems with statements with proofs also there, ma. But luckily మీకు లేవు, ఓన్లీ స్టేట్మెంట్స్ బై హార్ట్ చేయండి. ఇన్ కేస్ ఏదైనా బిట్స్ వైజ్ వచ్చినప్పుడు ఇట్లాంటి లాజిక్ యూజ్ చేసి ఆన్సర్ చేయండి అంతే. Okay, the eigenvalues of the orthogonal matrix can be what? +or -1. And unit matrix eigenvalue enti that is absolute value is 1. Okay, just by heart it all. And next, మీకు ఇది అయిందా? కాంప్లెక్స్ మ్యాట్రిక్స్ కి ఐగన్ వాల్యూ అండ్ ఐగన్ వెక్టర్ ఫైండ్ అవుట్ చేయడం అయిందా?
No, ma'am.
కాంప్లెక్స్ మ్యాట్రిక్స్ కి ఇట్ ఈస్ నాట్ కంపల్సరీ, రియల్ మ్యాట్రిక్స్ ఈజ్ ఎనఫ్. అదే ప్రొసీజర్ ఇక్కడ యూజ్ చేస్తాం. బట్ ఇక్కడ కాంప్లెక్స్ మ్యాట్రిక్స్ లో ఏంటి, ఒక ఐ అనే ఎలిమెంట్ ఉంటుంది కాబట్టి కొంచెం కన్ఫ్యూజన్ ఉంటుంది. ఐ విల్ ఎక్స్ప్లెయిన్ వన్ క్వశ్చన్ ఆన్ దట్. ఓకేనా? Okay, write down one question on that complex matrix. Find the eigenvalues and eigenvectors of the matrix. Find the eigenvalues and eigenvectors of the matrix. A is equal to I 0 0 0 0 I and 0 I is 0. But this is the matrix. For that, find eigenvalues and eigenvectors. Is it complex matrix or real matrix? Tell me. Is it complex or real?
Complex, ma'am.
Complex. For that, same procedure. Characteristic equation is det A minus lambda I is equal to 0, right? For that, I minus lambda 0 0 0 0 minus lambda I 0 I 0 minus lambda is equal to 0. For that, find determinant, or directly from the calculus also we got it. That is 0 minus lambda means minus lambda into minus lambda minus I square, and the remaining all are zeros. For that, I minus lambda and lambda square plus 1 is equal to 0. Equating both with 0, that is I minus lambda is 0 and lambda square plus 1 is equal to 0. For that, lambda is equal to I and lambda is equal to plus or minus I. Therefore, the eigenvalues for this I and minus I. These are the eigenvalues. Here once you see one value is repeated twice. Which one is repeated? I is repeated, right? Okay. Is it clear all of you for the procedure for finding eigenvalue? Any doubts? Okay. Here the eigenvalues for the 3 by 3 matrix. I and minus I. Okay. Next. Eigenvector. Case 1. If lambda is equal to I, then find eigenvector. Once, all of you know this, if one eigenvalue is repeated twice means in that one case only we got 2 independent eigenvectors, right? Is it clear all of you? Ante kada? Manaki oka eigenvalue repeat ayindante oka case lone we got 2 eigenvectors, K1, K2 form, right? Okay, in this case also we got 2 eigenvectors at a time. Okay, for that, what is the formula for that? A minus lambda I into x is equal to 0. Here what is lambda value? I. Okay, then substitute here. So directly substitute. This is a minus lambda I gada. I minus I 0 0 0 0 minus I and 0 I 0 minus I into x is equal to 0. For that 0 0 0 0 minus I 0 I minus I. And here number of unknowns how many ma? For 3 by 3 matrix means number of unknowns are 3 is equal to 0. Now reduce this matrix as in echelon form with respect to the row operations. Tell me the row operations for this. R3 tends to R3 plus R2, right? That is 0, 0, 0, 0 minus I, 0 plus 0, 0, I minus I 0, minus I plus I 0 into x1, x2, x3 is equal to 0. Next continuation. Okay, now I'll exchange the rows ma. It is not compulsory, but echelon form kannam kabatti, then R1 interchanges to R2. That means 0 minus I 0, 0, 0, 0, 0, 0 into x1, x2, x3 is equal to 0. For that, number of unknowns how many? 3, and number of non-zero rows are 2. Then n minus r is equal to how much? 3 minus 2 is equal to 1. Let us take one variable as arbitrary constant. First write it as the equation form, that is minus I into x2 plus I into x3 is equal to 0. From that take I outside, that is minus x2 plus x3 is equal to 0. That is minus x2 plus x3 is equal to 0. Let us take this is one equation. In that equation I am assuming let x3 is equal to k. Okay, x3 అన్నది k అని తీసుకున్నాం. Okay, మా here number of non-zero row 1
1
కదమ్మా.
1 ma'am. Number of non-zeros 1 ma'am.
మరి ఇప్పుడు చెప్తావేంట్రా, నాకు కన్ఫ్యూజన్ వస్తుంది. నెంబర్ ఆఫ్
అయితే
నాన్
two
జీరో రోస్ హియర్
అంటే
1.
2 కాన్స్టెంట్స్ ఉండాలి కదా ma'am.
This is
Arbitrary
3
constants
minus 1 is equal to 2. ఓకేనా? ఇప్పుడు x3 ని మనం ఓకే హియర్ నెంబర్ ఆఫ్ నాన్ జీరో రోస్ ఓన్లీ 1 మా, దట్ ఈస్ 0 minus I. n minus r is 3 minus 1 is equal to 2. Then let us take two variables are arbitrary constants, right? That is, now I'll take one variable that is x3 as k, substitute in the above equation, from first equation we get x2. What is x2 ma? After substituting x3 there, minus x2 is equal to minus k. From that x2 is equal to what? K. Is it clear? First equation x3 place lo k substitute cheyandi, appudu x2 is also k. Therefore x3 is k and x2 is also k. And what about x1? Okay, we have to assume that one also one variable arbitrary constant. Shall I rub the first part here? Rub cheyacha for finding eigenvalues. Okay, then let us take x1 అన్న వేరియబులే మనకి లేదు మ్యాట్రిక్స్ లో, బట్ డైరెక్ట్లీ ఇట్ ఈస్ హియర్ x1 లేదు కాబట్టి then let us assume that as the arbitrary constant. I'll take that as x1 as k1. Okay, therefore eigenvector x1, x2, x3 is equal to what? x1 as k1, x2 is k and x3 is k. ఈ టైప్ ఆఫ్ కేస్ లో మనం లీనియర్ ఫార్మ్ క్రియేట్ చేస్తాం నాన్న, దట్ ఈస్ 1 into k1 plus 0 into k. Why? Because here the vector is in terms of k1 and k. In that first variable which is missing, k is missing, that's why I'm adding with 0 into k. In that second variable k1 is missing, I'll write that as 0 into k1 plus 1 into k. And similarly for the third variable also k1 is missing, I'll write this as 0 into k1 plus 1 into k. ఇప్పుడు ఏం చేద్దాం, k1 k ని సపరేట్ చేద్దాం, దట్ ఈస్ 1 into k1 plus 0 into k1 into 0 into k1 plus 0 into k, 1 into k plus 1 into k. From that k1 common, మనకి యూనిట్ మొత్తం ఫైండింగ్ ఐగన్ వాల్యూస్ అండ్ ఐగన్ వెక్టార్స్. ఇప్పటికి కూడా కన్ఫ్యూజన్ ఉంటే నేను ఏం చేయలేను. నెక్స్ట్ హియర్ k కామన్, దట్ ఈస్ 0 1 1. Therefore here what are the eigen vectors for if lambda is equal to I? If eigenvalue is repeated twice, for that case, okay, we got 2 eigenvectors at a time. What are that? 1 0 0 0 1 1. Therefore if lambda is equal to I, for that case eigenvectors 1 0 0 0 1 1. Okay, this is the procedure for finding eigenvectors for the complex matrix. Note down ma. Next eigenvalue lambda is equal to minus I, right? అది only distinct element కాబట్టి only in second case we got only one eigenvector. ఈజీగా అయిపోతుంది, అది హోంవర్క్ చేయండి. Is it completed? మా కాపీ చేస్తున్నారా, అయిపోయిందా?
Completed.
Completed.
What are the eigenvectors of lambda equal to -1? Okay, finished ma? Finished. Next lambda is equal to minus I, అది ఒక్కటి చేయండి. ఓకే, ఎండ్ చేద్దామా సెషన్? Finished. Any doubts? Any doubts for finding complex value eigenvector? No doubts? Okay. I'll end the session ma. Thank you for all.
Madam.
Attendance. Okay, wait. How many are absent here? I'll write ma. D2, D4, D5. D1, D2 absent.
D2 present, madam.
Absent.
Aganra. D2, D4, D5, D6. D1 present, ah? E0, E1, E2, E3, E4. E4 ma. E4, E5, E6, E7, E8, E9. E9 present, ah? F0, F1, F2, F3, F4, F5, F6, F7, F8, F9, G0, G1, G2, G3, G4, G5, G5 ma.
Present, ma'am.
G5 present?
Yes, ma'am.
H1, H2, H3. ఇక్కడ రావట్లేదు కదరా నీది. H4, H5.
Name పెట్టండి మేడం.
H7. మరి రీనేమ్ చేయాలి. H8, H9,
Okay, ma'am. Return
J0, J1, J2 and J1.
Madam, J2 present, madam.
Rename with your rule numbers.
Okay,
J1,
madam.
J5, J6, J7, J8, J9, K0, K1, K2, K3, K4. Who is Sai Teja, your rule number?
G5, ma'am. G5.
Okay. Next, Sheikh Siraj.
Sai Teja rule number G5, ma'am.
Yes, madam. Sheikh Siraj J2.
J2, okay, ma. Okay, it's enough.
Madam, D2 present.
D2 present only.